Marine habitats are habitats that support marine life. Marine life depends in some way on the salt water that is in the sea. A habitat is an ecological or environmental area inhabited by one or more living species. This marine environment supports many kinds of these habitats. There are many types of marine habitat that exist on our world. Among the examples of the marine habitat includes mangrove, seagrass, corals, and other marine habitat that exist near ocean or in the ocean. Nowadays, remote sensing is one of the technology that has the ability to detect this marine habitat.
We understand active remote sensing as in radar transponder. It's sending out radar waves or radio waves which bounce off from the Earth's surface. The time required for the waves to hit the Earth's surface and be recorded by sensors on the satellite is what is utilized for making an image. Sun illuminates the Earth and reflectance from the Earth's surface is collected by the satellite.
Mangrove ecosystems occupy thin strips of land at sea level. Their land area makes up less than 1% of all forests worldwide. But it is their location along tropical and subtropical coastlines which makes them extremely important for us to study and understand. Mangroves prevent coastal erosion, and they are a natural buffer zone that absorbs the damage from tsunamis and storm surges. Today, mangroves are more endangered than any other ecosystem on the planet. Their proximity to the sea, with all its benefits, also makes them highly vulnerable. Fortunately, with the help of radar technology, we can help prevent that from becoming a reality. Radar remote sensing is an essential tool for managing these precious ecosystems. Remote sensing efficiently gathers information in regions spanning the globe that would be difficult to access otherwise. NASA uses the UAVSAR, which is an active remote sensing instrument. UAVSAR sends microwave pulses over the wetlands and detects the reflection. NASA flies the UAVSAR on manned and unmanned aircrafts like the Gulfstream 3 and the Global Hawk. They use a technique called radar interferometry, which requires two antennas to yield reliable estimates of the mangrove's canopy height as well as biomass. Analyzing the data in 4 dimensions, that including time, paints a complete picture of how climate change and human activity affect mangrove sites worldwide. Remote sensing can also reveal information about carbon sequestration, water quality, habitat composition, and more. These technological advances have improved our understanding of what services mangroves provide to us, but also what we can do for them. With this new scientific knowledge, non-governmental organizations, local decision makers, and policymakers can promote sustainable practices and provide for their people.
Coral reefs are among the most diverse and complex ecosystems in the world. But reefs worldwide are facing increasing pressures, like more frequent and severe mass bleaching events, caused by warming seas as well as local human-caused stressors. Mapping and identifying habitat that represents important biodiversity hotspots is important for coastal communities that rely on healthy reef fish populations, as it can help to inform urgently needed management actions to sustain healthy reefs and healthy coastal communities. Such actions could include deciding which areas should be protected from fishing. Management information is needed across large geographic areas. Remote sensing technology has become increasingly important in mapping, monitoring, and understanding global marine systems. Maps of the marine environment can show where different types of habitat are found. Coral reef areas with greater three-dimensional structure provide fish with more refuge from predation, compared to areas with smaller or fewer amounts of corals.
All these levels of detail can be mapped to a certain extent. So here you see the geomorphic maps and the reef type map, And here you see the Benthic community map and then the biotope map. Here you see the examples, zoomed in examples of the different maps I just previously showed. Information can be used to help management and researchers, where we looked at predicting fish biomass, or we looked at Solomon Islands for assessing impacts of sea level rise.
Seagrass also can be detected through remote sensing technology. Take as an example here, I choose Moreton Bay, which is located in Australia, for the case study in seagrass mapping. Satellite imagery or remote sensing is able to detect the existence of the seagrass at the area. However, field data is required as well. To acquire the field data, snorkeling, diving, or even taking pictures or videos from the site is required. What we have here is the coarse scale map, which we combine the field data and the satellite imagery. As you can see, the map is quite coarse due to the high pixel size, which is 30 meter times 30 meter wide. However, there are new methods that were available that we can get the data with higher resolutions. As you can see, higher resolution imagery can detect the seagrass species, the seagrass cover, and also the seagrass biomass as well. Remote sensing not only helping us in viewing and detecting seagrass and mangrove, but also helping us to conserving them in the future. Remote sensing not only able to detect mangrove, corals, and seagrass, but also many other marine vegetation and marine habitat. Remote sensing also able to detect chlorophyll in phytoplankton and other ocean features such as salinity, ocean color, ocean temperature, and other factors.